Well, thanks for sticking around so late. My talk is about web apps that have features that you would only expect from native apps. So web apps, but features you think you can't get unless you build native apps. And specifically, I'm talking about caching, so offline use, background syncing that doesn't have high battery drainage and polling, native push notifications, and also how you can get the device motion data, so accelerometer and gyroscope, everything in web apps. Okay, a little bit, native apps and web apps both have their advantages. If you build a native app, you can build it device-specific, so you build it to the strength of the platform, and if you do it right, this is how you can get the best performance and make the most out of this device. If you build a web app, though, one advantage is it's platform independent, so it's a little less work for you. You don't have to go through some app store to deploy your app. And also, your user doesn't have to go through the app store to download, install, and update your app if they want to use it. And if you're familiar with web development, when you write web apps, you don't need to learn a new language, so that's also a feature in some sense. And so not related to the features I'm talking about today, but in the spirit of before the internet, everything was a native app. Like in the 80s, you had to install, everything was a native app. And then we had more and more web apps, like think of Gmail running in your browser. And then smartphones came along, and everybody was going, yay, native apps, and the app store was full with apps. And recently, we've seen somewhat of a trend of going back more to web apps instead of native apps. And I think the biggest reason for this is that it's easier for the user. Like, you know this, you look up something on the internet, and the website says, ooh, install this app. And you're like, no, I just want to look it up. I don't want to enter my App Store password and go through all this hassle. So by hoping not to scare users away by making it a native app, oftentimes it's a good idea to build a web app. And in the spirit of this trend of going from more native apps to web apps, I just want to briefly mention a side project. It's a web interface for a math program. So this math program, Macaulay 2, is used in research for algebraic geometry and commutative algebra, so higher math classes, research. It usually runs in a terminal, so it's okay on a Mac or a Linux, but if you're using Windows, you have to go through like Cygwin or something, so it's really a pain to use it. And we decided it would be good to just have a web app where you can go and do your calculations. So Macaulay 2, you can do a lot of algebraic geometry, like you can compute the Gröbner basis of a polynomial in your favorite ring, like pretty high stuff math. And with this web app, all you need to go is to a website and you type in there, hit enter, it's evaluated on our server. You can even do it on your iPad if you want to. So big advantage, you don't need to download and install it, which in this case means reading like 2 pages of instructions. You just use it. So even your students can use it and they don't bug you how to install it. Oh, it doesn't work. Okay, but back to the features that I want to talk about. So caching, background syncing, push notifications, and gyroscope. Let's get started with the motion sensor, the gyroscope and accelerometer. You all know this. You can use them to detect shake gestures. It's used in games. It's used in health and fitness apps. And if you combine it with geolocation, you can do turn-by-turn navigation. So, I mean, you've all noticed you can shake your phone and something happens. And in HTML5, it's really simple to get to this data. There's a device orientation event and a device motion event that you can listen to, and it tells you how the user is moving their phones. It's also supported in all current browsers, so this is not anything fancy, special, new. Even Internet Explorer can do it, so no excuses. All right, let's get started with the device orientation. The device orientation is given to you as Euler angles, so you have alpha, beta, and gamma, where alpha is the rotation rate around the z-axis, beta around the x-axis, and gamma around the y-axis. So if this is your phone, we have, just like you expected from math class, x-axis and y-axis, and then perpendicular to it would be the z-axis. So an easier way to think of these angles rather than around x, y, and z-axis, you think of alpha, which was around the z-axis, then alpha is the angle your phone is turned. When it's flat on the ground, alpha tells you whether you're pointing north, south, west, or east. And usually alpha equals 0 means you're pointing north. So flat on the ground, pointing north, you get 0, 0, 0. And then you have beta and gamma. Beta is around the x-axis. So beta is when you tilt your phone front to back. And then gamma is around the y-axis, which is left to right tilt. So that's what the alpha, beta, and gamma angles mean when you get them on your device orientation event. And the code is super simple, like 4 lines of JavaScript. You add an event listener for device orientation. And when you get the event, which is cut off here now, your event has an alpha, a beta, and a gamma, which correspond exactly to which direction on a compass your phone is pointing, and then whether it's tilted front, back, side to side. So you get alpha, beta, gamma, and then you can do whatever you need to do with this data. Okay, so that was device orientation. There's also device motion, which gives you the acceleration of your phone. You get it as 3 numbers, x, y, and z. That's the acceleration in meters per second squared. And you also get the rotation rate in degrees per second. And x, y, and z, again, are in those 3 directions. So when the phone's not accelerating, x, y, and z are 0, obviously. Say the phone is moving, accelerating forward, so along the y-axis, then you get 0, some number 0, because it's going y-axis. Okay. Some devices can do the acceleration without gravity, so they do acceleration including gravity. Since gravity pulls down along the z-axis, so the third coordinate, you get 0, 0, 9.81 meters per second squared. Okay. And then if your phone is not lying flat, let's say you have it this way. So now if you move forward, if you're accelerating forward, this is along the z-axis, so your third coordinate is not 0. And for the acceleration including gravity, now gravity is pulling this way, so your y-axis is the 9.81 if your phone is standing still. Make sense so far? Okay. Okay, so you can listen for the device motion event. And when you get that event, it has an acceleration. And the acceleration has x, y, and z, so your acceleration in those 3 directions. It also has acceleration including gravity, and you can get the rotation rate. And then you can do with those numbers what you need to do.
Is that so? If the browser is computing an acceleration, and it's filtering the gravity out of the, because the accelerometer by itself always registers the gravity, right?
I think depending on the device, it can also either do it without or calculate that out or something. I don't think it's the browser. Well, if the chip doesn't do it, I think your browser only offers acceleration including gravity.
Okay.
Yeah, so that this first one might not be supported. So, okay. So you can go ahead and try this out. I've put sample code up there, and you all have the Wi-Fi here. So it's a bit.ly at devcamp.mook, and the code that's running there is really just what you see here. It's an event listener for the device orientation and the device motion it's rounding those numbers just so that it looks a little nicer, and then it's posting them on the website. So I posted the code here so you don't feel like I'm tricking you. There's really no magic. It's basically those same 5 lines that I showed you before for device motion and device orientation. So you should see something like this, the 3 numbers for device orientation and device motion. And we start out with the phone lying flat, pointing north. So we have 0, 0, 0, or close to it, 1, 0, 360. So starting flat, phone lying on the table. And then when I start turning it, but keeping it flat on the table, you can see the direction. So the compass direction is turning by 360 degrees until I make a full circle. And then turning left to right and turning front to back, you see how those numbers are changing. Okay, so very simple. So simple that there are a few drawbacks. I said alpha equals 0 is north. Where? Where is north according to the app? Okay, so north is this way. There are differences between the devices. On Mac OS, alpha equals 0 is always the direction that you first were pointing when you opened the app. So anybody on an iPhone should be pointing towards me, sort of. I don't know, Ruben, your phone is drunk, maybe. Wrong. Okay, but there's a simple way to get around. You can just get the compass heading and then subtract that from alpha, so you actually get north and not the forward direction. Then also the different operating systems can't agree on which way the rotation rate should go, clockwise or counterclockwise. And then also the axis for acceleration is the opposite on an iPhone. So gravity is minus 9.81, which is kind of weird. Okay. And another drawback, which sometimes might be important, what you can't do on the web is you cannot set the update interval for this event, which depending on what you do, it might be more or less important to frequently get the device orientation, and it's always the same one in the browser, and so it might be more often than you need to, which is draining the battery, or it might not be often enough. But for basic stuff, this is how you can get the device orientation. And a simple solution to this whole north and clockwise, counterclockwise thing is you wrap your acceleration code in a class that has device detection, and then you subtract or multiply by -1 or what you need to do. Okay, so I told you how to get the movement of the phone, and now we'll talk about caching, push messaging, and background syncing. And there's a service worker which you can use for that. So first of all, those 3 features, they're all features that make the user's experience a much better one if they are offline or if they have a slow connection. Say, for example, an email program. Even if you're offline, you still want to be able to read the emails that you've already received. And you also want to be able to write an email and place it in your outbox and to send it when you're online. Like on your phone, you don't need to be online to actually write an email, just to send it. The other thing that's important is that you get some notification that you have a new email, even if if your email app isn't open. Similar for Twitter. You want to read the tweets that you already got when you were last online, and you also want to write a tweet and have it sent once you're online again. And the same for any kind of image sharing, image cloud app. And also you don't want to download all the information you already had before every time you open the app, especially with images. You just want you want a set of them to stick around, all of them. Okay. Okay, so what is the service worker that supposedly can help you with all of this in web apps? It's a JavaScript worker run by your browser in the background. And its lifecycle is separate from your web page. So you can close your web page. That doesn't mean that your service worker is closed. It cannot access the DOM directly. And for security reasons, it only works with HTTPS. But it also works on localhost, and things like GitHub pages are HTTPS, so developing is no problem. Just remember only HTTPS. And it's supported by Chrome, Opera, and Firefox nightly. Okay, so the first thing you need to do is you need to register a service worker. So in your page, you say service worker.register of worker.js, assuming your service worker script is in worker.js. So you have worker.js where your service worker script is in. So you need to register for one. Oops. And then in worker.js, you do whatever you want to do with the service worker that you've registered. Like in this case, I'm only listening for the install and activate event and log that it started out correctly. Okay. And while you're working, Chrome has really nice developer tools that show you which service workers are active. You can terminate them here, and you have what you used to your console, so you can also debug the service worker code, set breakpoints, the usual stuff. Yeah, so when we load the page for which I just showed the code, on the console for the service worker, you will see that it's installed and activated because those were the log messages I said I would print. Okay, so let's get started with basic network intercepting. Super simple HTML page. I hardcode some text at the beginning. Something. You should get a different response when you refresh my sentence here. And then I register the service worker in worker.js. Okay, and in worker.js now, we listen to the fetch event. So anytime the website is requesting something, a fetch event is passed to service worker. And in the case we get this event, we get a fetch event, we want to respond with hello world. So instead of fetching the request instead of sending the request that the user wanted back to the server, we have service worker respond with this dummy response hello world. Okay, so what you get is when you first load the page, you get your basic HTML where I had said you should get something different. Now when we refresh it, we're not getting the HTML that we got the first time. We get the response that service worker is responding with to the fetch request. So we get hello world. And just for when you're working with refresh, obviously you refresh the page. And with shift refresh, you get your service worker to start over. So when I would refresh this, I can do this as long as I want. I would always get hello world. And then shift refresh would get me the original page back. Just useful. Okay, so this wasn't very useful. We are intercepting those requests and we say hello world. But we can use it for caching now. So instead of sending hello world back, we send back the cached files. So the first thing we need to do is create a cache, which is easy, caches.create. Give it a name. And we put all our static files in it, for example, like CSS and some images. Okay. And so now when we get a fetch event, rather than saying, ooh, hello world, we check the cache whether we have the requested page in there. And if so, then we return what we have cached. And only if we don't, then we actually ask the server to get us that resource. Okay. Why? Yeah. So that it's faster the second time you start it up because it's already in your cache? Yeah, if you're in a subway, lots of people, country. Okay, and just explaining the service worker lifecycle is download. So first you need to get the worker.js file, and then service worker goes through the install phase, which is usually where you want to create your cache. And then the activation phase is a good time to handle old caches, just to make sure you take stuff out that you don't want there anymore. Okay. So then there's also push notifications, which you can do with service worker. Usually the way push notifications work is, first of all, the app, you need to give the app permission to spam you with push notifications. And when you click the yes, allow push notifications, then your app gets a push subscription, some kind that has an ID in it. And what you need to do is your app needs to tell your server what its push subscription is, so that you can figure out, okay, this subscription goes with this user. You probably need to keep track of that unless you always broadcast everything to every user. But so you give the app permission, the app gets a push subscription, and you need to know on the server which user goes with this push subscription. Now, if the server has something he wants to notify the user of, he doesn't send it back to the user because he doesn't know where he is, which device that is. Instead, the user sends the notification data that he wants to send out to a push notification service together with the subscription ID. And then the push notification service, based on this ID, knows which device to send the notification to. And you can use Google Cloud Messaging or Apple Push Notification Service as your push notification service. Okay. So, and to make this work in your web app, in the page you need to register for push. So you say push.register, and if the user grants permission and if the browser supports that feature and if everything goes well, you get a push subscription, which you somehow need to communicate back to the server. So this send subscription somehow tells the server which user goes with that and so on. You need to implement that. Okay, so now the server knows which subscription ID to use for that user. And when a server has something, he's sending it to that. He's notifying the push notification service that he wants to give a message to that subscription ID. And then the push notification service is what's waking up service worker and sending a push event. So service worker in worker.js needs to listen to push. And when he gets a push, he can do new notification of the content that was sent with this or something. And it's good practice to update your caches before you send a notification. You probably know this from WhatsApp. A lot of time you see a new message on the locked screen and the beginning of the message. And then you're down in the subway, you lose your connection, you open the app, and the new message isn't there yet, even though you've seen the notification. So this is exactly what you can avoid by first updating the cache and then sending the notification. So you get the notification, you open the app, and you already have the new content that you've been notified about. Okay. So this is how you get native push messaging in your web apps. You get cute little message thingies. Okay. Last but not least, background syncing. I've mentioned before email clients. You expect when you're writing an email and you're offline, you expect it to be placed in your outbox and to be automatically sent when you're online again. So say we have an app that's sending emails or some other messages. Well, you try to send your email, but this doesn't work because you're offline. So in Catch, instead, you save it to your outbox, that email that you were writing, and then you register for sync. So you're saying, do something when we're syncing on the ID empty outbox. And now in Worker.js, well, you listen for sync. And if you get a sync event, you check that it has the right ID, so empty outbox. Then you get whatever you placed earlier in your outbox, something you have to implement yourself, and then send every email that's in there. So you can write this email, try to send it, it'll be placed in your outbox, like navigate away from the page. At some point you're online again, and Service Worker will get the sync event and then run this code. Okay, so this was a one-time sync. You said, send my messages, empty my outbox when I get it. There's also a periodic sync event. For example, you might want to get your new emails or get updates on a news website every hour. So you can say sync, but with an interval of 1 hour. Yes, 60 minutes. Okay. So I hope I was able to show you that things like those detecting shake gestures and caching for making your website faster or even work fully offline, push notifications and background syncing, they actually, you can implement them in web apps. You don't necessarily need a native app for that. Thank you.